Hello students, and welcome to the concluding videos on special right triangles. And in this video we're just going to look at a bunch of examples of special right triangles and how to find their values. Okay. So here we're given a table and we're asked to complete this table based on this picture. Okay. So from here, hopefully what you see is that we have a 45, 45, 90 right triangle. And so what that means is x times the square root of 2 is equal to y. Okay, so this nice little fact comes from the 45, 45, 90 theorem. And we're going to use this fact repeatedly in this case to find some answers to this. And everything in this example should be written in simplest radical form. So if x is equal to 5, then what is y? Well, y is equal to x root 2, so in this case, x root 2, but x in this example is equal to 5, so the answer here is 5 root 2. Okay. And let's look at a slightly harder one. What if we're given y? Okay. So remember that y, in this case 4 root 2, is equal to x root 2. So the root 2 cancels, and that means that x is equal to 4. Let's keep on going here. This example here, x is equal to root 2, but x times root 2 is equal to y. So remember, so this root 2 here is x. This root 2 comes from the theorem, and we know that when we multiply them we get y, so root 2 times root 2 is just 2. And then maybe a yet slightly harder one in this case. We know that x times root 2 is equal to y, which in this case is 9. To get our answer, we divide both sides by root 2, so x is equal to 9 over root 2. However, this right here is not in simplest radical form, so we need to convert it to simplest radical form by taking the value and multiplying it by 1. Okay? Look at the previous video if you're not familiar with this idea. But if something is not in simplest radical form because there's a radical in the denominator, then you need to multiply it by 1. And this right here is just the same thing as 1. It's root 2 over root 2. Okay, so this is just equal to 1. So when we multiply this out, we get 9 root 2 on the numerator, for the numerator. And in the denominator, we get root 2 times root 2, which is just 2. So we can write this answer as 9 root 2 over 2. Okay. I have one more example here. I'd like you to do this for your homework. Okay. Do this on your own. I'm very confident that you should be able to figure it out if you know the theorem and you know how to convert everything to simplest radical form. So in the next problem here, number 10, we are asked to solve some missing values here with A, B, and C. And this time, though, we have a 30, 60, 90 right triangle. So this theorem says that the shortest side, the hypotenuse is twice the shortest side. In other words, C is equal to 2A. And the longer leg, B, is equal to A times root 3. Okay? So we're going to use these two equations to solve a bunch of problems, and this is the 30, 60, 90 theorem. Okay? And we're just going to use that a bunch of times. Okay? So let's start out here. What if we're told that A is equal to 9? How do we find B and C? Well, C is probably the easiest to solve for. Remember, C is equal to 2A. In this case, A is equal to 9, so C is 18. And then B is equal to A times root 3. A is equal to 9 times root 3. So that's pretty straightforward. So this is just 9 root 3. Okay. Let's try a different example now where we are given B and we're asked to solve for A and C. Okay, so we're given B this time and we want to know A and C. Well, B is equal to A times root 3. B is equal to 9. And we need to solve for A. So to solve for A, we divide both sides by root 3. And we get that A is equal to 9 over root 3. But that's not simplest radical form, so we need to multiply by 1 here in order to get it to be simplest radical form. So this is going to give us 9 root 3 in the numerator, and root 3 times root 3 is just 3. And we can simplify it one more step because 9 over 3 is 3. And so this is the value of A. Okay, so this is A is 3 root 3. So if this is B, then 3 root 3 must be A. Now to find C is much simpler than that. Remember that C is equal to 2A. So it's 2 times A, which we figured to be 3 root 3. So this is equal to 6 root 3. So those are the results of that one. I'm going to do, let's see, I'm going to do the next column here. So same thing again, this time we are also given B and we're asked to solve for A and C. So B is equal to A root 3. B is 5 root 3 is equal to A times root 3. It's very nice in this case because the root 3's cancel, so that means 5 is equal to A. So this is 5. And then C is just twice of A, twice as big as A, so this must be equal to 10. I am going to skip this next column here because I'm very confident that all of you should be able to do this. So we'll make this your part of your homework. Okay, do it on your own, and I'll show you how to solve when we're given C. So I'll do it all in this little box here. So let's see. C is 16, and that's twice as big as A. So that means A is equal to 8. And then B is equal to A times root 3. So 8 times root 3. Okay, because A was equal to 8. So 8 root 3. Okay. So there you have it. Some examples of how do we solve these right triangles and solve them quickly using the special right triangle theorems. Again, you could use the Pythagorean theorem for all of this, but it is highly recommended that you do not do that because that would just waste a lot of time. Okay, you need to be able to do these types of problems using the theorems that you've learned. Thank you for watching. Have a wonderful day.